In this lecture, we will talk about two examples. One is find the exact value of tangent beta over 2 if tangent beta is given negative radical 5 over 2. Here we know that beta is in between 90 degrees and 180 degrees. Basically, this says that beta is in second quadrant. We know beta is in second quadrant. Tangent beta is negative. Sine beta is positive. Cosine beta is negative. Okay. Now, with these things in our mind, we know here we are given is tangent beta over 2 is a half angle. So we got to use the half angle formula. There are few half angle formulas. They are involved. Those angles are involved about sine beta, cosine beta. So we need is based on tangent beta equals negative radical 5 over 2. We want to find sine beta and cosine beta. Okay, now let's do that. And here is the picture. I want to draw a picture right here. Here is beta. Then radical 5 will be here and 2 will be here. Because tangent beta is the opposite side, radical 5 over adjacent. Alright? So basically, when we try to find out sine beta, cosine beta, we do not consider the sine first. Then later on we got to add the sine. Okay? So, then if here is A, here is B, then C equals what? Okay, so you go to C is by what? By Pythagorean theorem. Okay. What do we have? We then have a squared plus b squared equals c squared. This tells us that c squared is 2 squared plus radical 5 squared equals 2 squared is 4 and radical 5 squared is 5, so equals 9. And then this gives us what? C equals 3. Okay, because c squared is 9. So C is 3. Now then what do we get is sine beta is opposite side over hypotenuse. Opposite side is radical 5 over C is 3 already, so 3. Then sine beta is in second quadrant, and the second quadrant sine beta is positive. Sine beta is positive in 1 and 2. Quadrant 1 and quadrant 2. Cosine beta is negative in quadrant 2. Okay, so you put negative here first. And then opposite side, and then adjacent over hypotenuse. Adjacent is 2. hypotenuse is 3. Okay. So then we are ready to apply the half angle formula. Okay. So we then have a tangent beta over 2 equals sine beta, and here is 1 plus cosine beta. Okay? Yeah. So I want to separate those two lines. So that's the formula. We're going to remember that. And then sine beta is radical 5 divided by 3 from here. Cosine beta is 1 plus negative 2/3. Okay. Now radical 5 over 3. Downstairs is 1 plus negative 2/3. That's 1/3. Huh? Okay. Now, both numerator and denominator multiplied by 3. You may then cancel this 3 with this 3. And this one with this one here. So what do we get is radical 5 upstairs, downstairs is just 1. So then we get is radical 5. We don't have to write 1, because any number is the number divided by 1. Okay. 2 is 2 divided by 1, 3 is 3 divided by 1, 4 is 4 divided by 1. Radical 5 is radical 5 divided by 1. So we don't have to write 1. Okay, now there's the by half angle formula. When we find out this, here there are 2 steps. Okay, and this is a very good technique to find out C, and then write sine beta, cosine beta based on their quadrant. Okay, now the second one is to rewrite expression plus minus radical 1 minus cosine 6x divided by 2 as a single trigonometric function. Okay, so basically here you want to apply a formula, then it's going to be done easily. Look at this formula. By half angle formula, sine A over 2, this is a half angle, equals positive negative 1 minus cosine A divided by 2. Okay, if here is 6x, here, then here will be 6x. That's it. Very easy. Okay. So, you plug in 6x, you're done. So that's basically right here. Okay. So you input 6x here, you then rewrite it 1 minus cosine 6x divided by 2. And then here will be sine 6x over 2. Don't write in sine 6 over 2. You have one more step to complete. This step would be what? Would be sine 3x. Okay, because 6x divided by 2 is 3x. Okay, so you then have what? You then have a positive negative radical 1 minus cosine cosine 6x divided by 2 is just sine 3x. Okay, so basically here we have applied two half angle formulas. One is sine half angle A, another is tangent half angle beta. Okay, see you next time.